going to work with factoring using the A times C method, and when A is greater than 1. So remember, A times C, remember, when we talk about A times C, we're talking about in the quadratic form or template, where the coefficient of x squared is my A value, where the coefficient of my x value is my B, and my constant is going to be my C value. So when we talk about A, we're talking about the coefficient of the squared value, and C is going to be the constant. So in this case, A times C, let's go through, I jumped. We are using the A times C value, but we're going to go through this list of questions. First of all, is it in standard form? Is this expression in standard form? Yes, k squared, k to the first, no k value. So that tells me it's in scientific standard form. Question number 2, is it a special case? Our choices of special cases is binomial square or difference of squares. And we need to remember that binomial square and difference of squares both have first and third terms are perfect squares. So both, doesn't matter, both of those special cases have first and thirds as perfect squares. So we can check that. Not a perfect square, so we know it's not a special case. So now we move on to our next one, which is A times C. So these are techniques on how to factor. The problems that we've been doing up until this point, A has been equal to 1. The coefficient of my x squared or my squared value has been 1. So now we're working with problems where A is greater than 1. So A in this example is 5. C is also 5. So I take my A times C, which is 25. I find factors of 25, 1 and 25, 5 and 5. I look here. This means my signs are the same. Whenever it's a positive, I know my signs are the same. They're not both positive. To find out whether they're both positive or both negative, I have to look to my first sign. So they're both negative. So I'm going to go and make my factor pairs, which also happen to be my outside and inside values, the same signs. And now I'm looking to see which one is equal to my middle value, negative 26. My middle value is negative 26. So I'm going to use these as my outside and inside values. So I'm going to rewrite this trinomial into 4 terms. And I'm using these numbers as my coefficient of k. And if I combine these, notice it still equals negative 26k. So that's a quick little check there to make sure I did it correctly. Now we're going to factor by grouping. We're going to group the first 2, group the second 2. I look for a coefficient, for a greatest common factor of 5k squared and negative k. Greatest common factor is going to be k. I'm going to factor out a k. Factoring is a form of division. So we're dividing each of those by k. And then I look at my second pairing. I notice that my first term is negative. So when my first term is negative, I have to include a negative in my GCF. So I'm going to factor out a negative 5. If I divide both of those terms, I get 5k minus 1. I know I did it correctly because the 2 values inside of the parenthesis are the same. So I'm going to pull that out. I'm going to factor that out. And what does that leave me with? K minus 5. K minus 5. And now I check. I do a little quick check. I FOIL that back out to make sure that I get my first, my trinomial. See if it gets. That gives me 5k squared. My outside is negative 25k. My inside is negative k, which gives me negative 26k. And then my lasts give me a positive 5, which checks with that. Okay, so that's quickly, I don't know how long that problem took, but once you get there, once you do this efficiently, you can do these problems relatively fast. All right, next problem, scientific, I keep saying scientific, standard form, sorry. Is there a common factor? No. Is it a special case? Third is a perfect square, but my first is not a perfect square. So I have to go to a times c. A is 3, c is negative 4, gives me negative 12. Factors of negative 12 are 1 and 12, 2 and 6, 3 and 4. I don't worry about the signs until I go here. Negative means the signs are different, and I know that the bigger of the two is negative. Bigger, 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 smaller, signs have to be different. Negative 11, negative 4, negative 1. My middle is negative 1, so I know I'm going to use these as my outside and inside. So I'm going to rewrite this using those coefficients. I'm going to group. I'm going to factor out a 3x. So not only can I factor out a variable, but I can factor out an x, a 3. So if I take 3x from x squared, that leaves me with x. If I take a 3x from 3x, that leaves me with a 1. I'm going to factor out a negative 4. My first term is negative, and that leaves me with x plus 1. We can check real quick. Negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. It takes 2 seconds to check back to make sure you did it correctly. I have the same in the parentheses. I'm going to pull that out, and I'm left with 3x minus 4. That's how fast we can do these. So first thing, standard form, yes. Common factor, close. 5 goes into 5x, 5 goes into 20, but 5 does not go into 52. So there is no common factor. Is it a special case? Nope. 20 is not a perfect square. So I'm going to do a times c. A is 5, c is 20. That gives me 100. Factors of 100 are 1 and 100, 2 and 50, 3 no, 4 and 25, 5 and 20, 6 no, 7 no, 8 no, 10 and 10. Signs are the same, and they're both negative. So I'm going to throw those signs in there. Negative 101, negative 52, negative 29, negative 25, and negative 20. My middle is 52. So I take these two values. I circle them because I'm going to utilize them in creating this next line. Negative 2x minus 50x plus 20. These have to be used. We are going to use these two values, negative 20 and negative 50. Negative 20, negative 50. I saw students not use them. They use some other pairing. The reason why we use this is because this is equal to my middle, negative 52. That's what tells me which two factor pairs to use. I'm going to factor by grouping. I'm going to just take out an x. I can't take anything more. That leaves me with 5x minus 2. First term negative, I'm going to factor out a negative 10. That leaves me with 5x minus 2. 5x minus 2, and then x minus 10. As easy as that. Let's standard form, yes. Common factor, no. Special case, nope. A times c, a is 3, c is negative 3, gives me negative 9. 1 and 9, 3 and 3, signs are different. Bigger is positive. So the bigger of the two, Mr. Mack, 3 is not bigger than 3. Well, you're right. So you give one sign, it doesn't matter because they're the same. That gives me 8. This gives me 0. My middle is 8. So I'm going to use negative 1 and positive 9. So 3k squared plus, minus k because that's a negative 1, plus 9k minus 3. Group them. We're going to factor out a k. We get 3k minus 1. Factor out a 3. First term is positive, so I factored out a positive 3. And that gives me 3k minus 1. 3k minus 1 I pull out, and that leaves me with k plus 3. Your teachers next year in 2 years in Algebra 2 are going to be so impressed with what you can do. So, standard form, yes. Yes. Common factor, no. Special case, no. A times C. A is 3, C is 10, 30, factors of 30, 1 and 30, 2 and 15, 3 and 10, 4 no, 5 no, yeah, 5 no, 5 yes, 5 and 6 were around the horn. Signs are the same, and they're both positive. (31, 17, 13, 11). My middle is 31, so I'm going to take 3p squared plus p plus 30p plus 10. Factor out a p, I get 3p plus 1. Factor out a 10, positive 10. You need that sign. Saw too many students who didn't have that sign. Whether it's positive or negative depends on what you are factoring out. You get 3p plus 1. 3p plus 1 times the quantity p plus 10. Remember, take a second to check and make sure that when you FOIL this back out, you get that starting problem. It takes 60 seconds, 30 seconds to multiply those two out. All right. Standard form, yes. Common factor, no. Special case, nope. A times C. A is 7, C is negative 12. That gives me negative 84, pretty sure. 1, 84, 2, 42, 3, yes, because 8 plus 4 is 12, 3 goes into 12, so 3 goes into 84. That's the 3 rule. You should know that. So 2 and 8, 28, 4, yes, 4 and 21, 5, no, 6, yes, 6 and 1, 14, 7, no, 8, no, 9, nope, 10, 12, 12 does, 12 and 7, oh, I missed my 7, see, there you go, so I was about to write 12 and 7, because 7 times 12, and what you should have seen, right, you have to be careful of this, because this is not in numerical order. So this is a good mistake that I made, 7 and 12. So make sure that even if you miss it, make sure that they stay in numerical order. I'm a little nervous about this one. I was not really strong in it, but we'll check. This is a great way. You can be uncertain, and you can still move forward. My signs are different, and my bigger is positive. So signs are different, bigger is positive. So since I made all my larger factor pairs on the right, I know that I can just go down the line. This makes 83, 40, 25, what's that, 17, what's that, 8 and 5? Again, 25, okay, found it. Yep, negative 3 and positive 28 makes 25. Just checking, 2 seconds to check. 7p squared minus 3p plus 28p minus 12. We can factor out a p. You get 7p minus 3. Well, I know that this has to be 7p minus 3. So 7 times what gives me 28? Well, 4. So I can do a little bit of using logic here. And does 4 times negative 3 equal negative 12? Yep. So that's a nice little sort of, you can leverage what you already know. That's assuming that this is correct. If you make a mistake here, then you're going to make a mistake here. So just be careful. But we can utilize knowledge and understanding where things are going to go. So that'll be your answer. And then I check it. 7p times p is 7p squared. Outside is 28p. Inside is negative 3p. Gives me positive 25p. Negative 3 times positive 4 is negative 12. I just checked this binomial, the product of two binomials, to check my answer, and I got it right. So take a couple seconds just to do it. So standard form, yes. Common factor, no. Special case, definitely not. A times C. A is 3, C is 20, 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9, 10. Good. Signs are the same, both positive. Your number sense is extremely important. If you know your numbers, you know your times tables, and you know how to find factors of things, it's going to be very beneficial in the sense of efficiency. You're going to be able to complete these problems faster than most. That comes with practice. So if you don't practice, if you don't work on it, then you're not going to get better at it. Common factor of b, we get 3b plus 2. Common factor of 10, we get 3b plus 2, 3b plus 2, and that leaves me with b plus 10. Standard form, yes. Common factor, no. Special case, nope. No perfect squares. And a times c. A is 3, c is negative 8, negative 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are different, and the bigger is positive. 23, 10, what's that, 5, 2, my middle is 10. So I'm going to use negative 2 and positive 12. Negative 2 and positive 12. I'm going to factor out a p, 3p minus 2. I'm going to factor out a 4, and that gives me 3p minus 2, 3p minus 2, p plus 4. Look how fun these get. When you get good at them, they're actually really fun. Well, I see them as fun. Standard form, yes. Common factor, nope. Special case, first is a perfect square, but third was not a perfect square. And a times c. So 4 times 3 is 12. 1 and 12, 2 and 6, 3 and 4. Signs are the same, both are negative. Negative 13, negative 8, negative 7. Negative 13, I'm going to use negative 1 and negative 12. Negative 1, negative 12. Notice I didn't write negative 1 because this is the proper way of writing negative 1n. Factor out an n, you get 4n minus 1. Factor out a negative 3. Ooh, how many people wanted to put 4 there? I know that there's a couple of you. 4n minus 1. 4n minus 1 is in both of them, and that leaves you with n minus 3. That'll be an interesting one to see how many people get number 9 wrong. I bet you there's going to be a bunch. Standard form, yes. Common factor, no. Special case, 9's a perfect square, 8 is not a perfect square. A times C, 8 times negative 9 is negative 72. 1 and 72, 2 and 36. 3 and 24, I think. Yep. 4, yes. 4 and 18. 5, no. 6, yes. 6 and 12. 7, no. 8, yes. 8 and 9. Signs are different. Bigger is negative, so we can go down this right side because all my right terms are going to be bigger than my left terms, and the signs have to be different. Negative 71, negative 34, negative 21, negative 14, negative 6, negative 1. My middle is negative 1. I'm going to use positive 8, negative 9, positive 8, negative 9. I'm going to factor out an 8v. That gives me v plus 1. I'm going to factor out a negative 9. That gives me v plus 1. V plus 1, 8v minus 9. Ooh, I like that. That's a good one. Another good one. Wow, we got some good problems today. Standard form, yes. Common factor, no. Special case, 9 is a perfect square, 10 is not a perfect square. So let's do A times C, 9 times 10, 90, 1 and 90, 2 and 45, 3 and 30, 4, no, 5, yes, 5 and 18, 6, yes. Because this number is divisible by 2 and 3, we know that it goes into 6. That's called the 6 rule. 6 goes into 90 15 times. 7 no, 8 no, 9 yes, 9, hello, 9 yes, 9 and 10. Signs are the same, both positive. And it has to equal 33. That's this one. We can start looking at our middle to see which one we want it to be, or at least will be tending to be. We can find those tendencies, those you should start seeing and recognizing patterns. Recognizing how this is going to work. We're going to factor out a 3x. You get 3x plus 1. You're going to factor out a 10. You get 3x plus 1. 3x plus 1. 3x plus 10. Yes. Standard form. Common factor. Special case. A times C. 8 times negative 3 is negative 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are different. Bigger is negative. Negative 23, negative 10, negative 5, negative 2. Negative 23. I'm going to use positive 1 and negative 24. Positive 1. Negative 24, factor out a b, I get 8b plus 1. Factor out a negative 3, I get 8b plus 1. 8b plus 1, b minus 3. 13, standard form, yes. Common factor, close. Special case, not even close. 4a times c, 10 times 2 is 20. 1 and 20, 2 and 10, 4 and 5. Signs are the same, both negative. Negative 21 is my middle. 10a squared minus a minus 20a plus 2. Factor out an a, I get 10a minus 1. Factor out a negative 2, I get 10a minus 1. 10a minus 1, a minus 2. Can't wait to get to number 17. Standard form, yes. Common factor, 52. 5 plus 2 is 7. Nope, 3 doesn't go into 7, so 3 doesn't go into 52. Special case, 9 is a perfect square, but 12 is not. Also close. Both of those were pretty close. A times C, 9 times negative 12, negative 108. Blah. That's a lot of factor pairs. 1, 108. 2, 54. 3, yes, because 1 plus 0 plus 8 is 9. 3 goes into 9, so 3 goes into 108, and that goes 36 times. 4, yes, 4 and 27, pretty sure. 5, no. 6, yes, because it goes into 2 and 3. 6 goes into 1. 6 times 8 is 48. 7, 7, I don't think 7. 8, no. Ooh, a lot of people probably tried 8. 9, 1 plus 8 equals 9. 9 goes into 9, so yes, 9 and, 12, hello. 10 and 11. No, let's see if we got them all. Signs are different. Bigger is negative. Signs are different, so if the biggers are negative, that means the smallers are positive, because the signs have to be different. Negative 107, negative 52, negative 33, negative 23, negative 12, whoops, wrong way, and negative 3. Negative 52, right there. 2 and negative 54. 2 and negative 54. Remember, this has to equal those. I'm doing that check as I write it. I'm going to factor out an n. I get 9n plus 2. Factor out a negative 6. And I get 9n plus 2. I'm checking it. Whoop. Notice I made a boo. No, that's okay. Negative 6 times positive 9 is negative 54. Negative 6 times positive 2 is negative 12. Just checked it. Everybody makes mistakes. And 9n plus 2 is the same in both the parentheses, and that leaves me with n minus 6. All right, 2 more of the regular ones. Wait until 17 comes. Oh, baby. Standard form, yes. Common factor, no. Close, 9, 9. 9 does not go into 91. Looks like it should, but it doesn't. Special case, 9 is a perfect square, 90, not a perfect square. 4 is A times C. Oh, goodness. 9 times 90 is 810. Blech. Throw up. 1, 810. 2, 405. Look, I see that my signs are going to be the same, and they're both going to be positive. So I need to add my 2 factor pairs to make 91. Well, this is going to give me 811. This is going to give me 407. So I can keep going with 3s and 5s, but this is going to be a big number on this other side, and that's going to be a big number. So I need 91. Well, I can think of 10 and 81, because 10 times 81 is 810, and 10 plus 81 gives me 91. So if you are able to see those pairs that are going to work, then jump to it. By all means, be rewarded in the fact that you have good number sense. You are absolutely able to jump to the factor pair. This better work though, and check. Don't just rush through it. You should be checking still. 10b and 81b definitely makes 91b, so that still checks out. And we know that 10 times 81 definitely equals 810. So this is a factor pair. We're going to factor out a b. We get 9b plus 10. We're going to look here and let's factor out a 9. And you get 9b plus 10. I did that correct because they're the same in the parentheses. And I'm left with b plus 9. And then I would check. 9b squared. Good. 81b. 10b makes 91b. And then I do my lasts. 10 times 9 is 90. So yeah, it checks out. Less than 30 seconds to do that. All right. Standard form. Yes. Common factor. Nope. Close. No common factor yet. Next one. Hint. Special case. Nope. Neither are perfect squares. A times C is 8 times negative 27, which is a big number. 56. 8 negative 16. 216. We can always take a calculator. It takes 2 seconds to check. 216. Yes, I love it. And make that a negative. Factors of 216. 1 and 216. 2 and 108. 3. 2 plus 1 plus 6 is 9. 3 goes into 9, so 3 goes into 216. Goes in 72 times. 4, yes. 4 and 54. 5, no. 6, yes, because it goes into 2 and 3, so 6. No, that doesn't want to work. Oh, there we go. 6 and 216. 6, 3, 3, 18, 18, 36. 36 and 6, I think so. Ooh, 216 is a perfect cube. 7, I don't think so. 7, 8, 8, yes. 8 and 27. 9, oh yeah, 8 and 27, that was my starting pair. 9, 2 plus 1 plus 6 is 9. 9 goes into 9, so 9 and 18, 24. 10, no. 11, no. 12, yes. So we have 12 and 18. 13, 14, I'm pretty sure that's all of them. 16 maybe? No. So signs are different and the bigger is positive. Signs are different, bigger is positive, and we need them to equal 30. That was my middle. 30, pretty certain it was 30. So here's my pair. I can stop right then and there. Negative 6, positive 36. Negative 6, positive 36, minus 27. I'm going to take out a 2n, which gives me 4n minus 3. And I'm going to take out a 6, no, 9. I'm going to factor out a 9, and I get 4n minus 3. 4n minus 3, 2n plus 9. All right, this is the one that we've been waiting for. So, 1, standard form. Yes, it is. 2, common factor. Ding, 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 ding. This is the first time that we've been able to factor out a common factor. We can factor out a 3. A 3 goes into all of these. So you get 2p squared minus 3p minus, what's that, 27? I think it's 27. 6, 7, 8, yep. And now we are going to just work with this. This is our new trinomial. So we go back to standard form. Common factor is a common factor. No. And now we start with this from this trinomial. So is it a special case? Nope. A times C. Oh, you got to be kidding me. That is absolutely, which is negative 54 1 and 54. I think that's the first time that's ever happened on a recording. 3, 5 plus 4 is 9, so yes, 3 goes into 9, 3 goes into 54. 3 goes into 54 once, 18, I think. 24, 2, yep. 4, no. 5, no. 6, yes. 6 times 9. And signs are different. Bigger is negative. Positive, 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 positive. Here's my -3. So we're still going to keep that 3 on the outside. That becomes 2p squared plus 6p minus 9p minus 27. If we simplify this, this needs to equal that one, not this one, because that's different. We factored out the 3. It just has to equal that one. Now, let's factor by grouping still. We're grouping these two and these two. So I'm going to factor out a 2p, and that gives me p plus 3. I'm going to factor out a -3. Oh, nope, I'm going to factor out a -9. If I did a -3, that would have given me 3p, and that's not the same. So I knew, quick little check there, I knew that that wasn't the case. So this gives me p plus 3. So I still have my 3 on the outside. I have my p plus 3 that are the same in the parentheses. And then I have a 2p minus 9. And that would be my answer. Same thing. Standard form. Yes. Common factor. Yes, I have a common factor of 6. I have a common factor of 6. I'm going to factor the 6 out. I get n squared plus 9, no, 6, what? Not 9, wait, 6 times, no, 30. Oh, nope, we have a 3, common factor of 3, sorry. 3 gives me 2n squared, 3 gives me 15n, I think, and 3 goes into, no, it is 9. No, 9 doesn't go into 6. I'm right. Sorry. I'm not trusting myself. 1 and 8. 18. We'll definitely check this answer. So, not a special case. And notice I'm checking, is there still, that's a nice little check too, 2, 15, and 18. So I know I did take out the greatest common factor. Because after I was left, I didn't have anything that was still. So I'm actually more certain about myself. Special case, no. 4, a times c, 2 times 18 is 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Signs are the same, both positive. Right there. 15, I'm looking for my middle, so I can kind of jump to that. 2n squared plus 3n plus 12n plus 18. I'm going to factor out an n, and I get 2n plus 3. I'm going to factor out a 6, and I get 2n plus 3. 3 goes outside, 2n plus 3. What they have in common, when I pull that out, I'm left with n plus 6. Awesome. Hope that helped. I know we got 2 more. Let's keep going. We got 2 more. Standard form, yes. Common factor, yes. Let's factor out a 2. We get 9x squared plus 7x minus 2. Looking at those 3, that was the common factor. No perfect, 9's perfect square, but 2 is not, so not a special case. 4 is going to be a times c, 9 times -2, -18, 1 and 18, 2 and 9, 3 and 6, 4, no. Signs are different, bigger is positive, minus, 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 we get 7. 2 times the quantity, 9x squared minus 2x plus 9x minus 2. Ooh, that's a, ooh, baby, look at that one. This is going to be fun. Let's look at those. We're going to factor out an x. We get 9x minus 2. No common factor here. So we can factor out a 1. And that gives us 9x minus 2, which helps satisfy our, are they the same? Yes. So that's a nice little trick one. I'm glad we stayed and did it. 9x minus 2, x plus 1. And last but not, oof, look at that big number, 1680, 138. Wowzers. Okay. Okay, standard form, yes. Common factor. Well, you definitely want to say 2. So let's start with 2. What if we factor out a 2? You get 8x squared plus 69x plus 40. And now, to see if I did it correctly, I'd look at all those. I'd look and see, is there a common factor from 8, 69, and 40? Well, 69 is such a weird number, right? 3 goes into it. 3 goes into it 23 times. So 3 doesn't go into those. So I'm pretty sure I've gotten my greatest common factor. Is it a perfect square? No. Special case? No. A times C. Ugh. 8 times 40. 320. Yowzers. Okay. We still have another test. This is important. I'll show you coming down to it why we can, why it's important. 3 does not go into 320 because 3 plus 2 plus 0 is 5. 3 does not go into 5, so 3 doesn't go into 320. 4, yes. 80. 5, yes. 5 goes in 64. 6, no, because it doesn't go into 3. Remember, all 6s go into 2 and 3. 7, no, I don't think so. 8, yes. 8 and 40. 9, no. 10, yes. 10 and 32. Let's just check as we go. Remember, adding that equals 69. Well, we could have stopped a long time ago because we got it right here. So let's do 2, 8x squared plus 5x plus 64x plus 40. Okay, so we're going to factor those 2 out and factor by grouping. You're going to factor out an x. That gives you 8x plus 5. You're going to factor out a, let's think of an 8. I like 8. 8 sounds about right. So if we factor out an 8, we get 8x plus 5, right? 8 times 8x is 64. 8 times 5 is 40. And we did it correct because those are the same. And now we have 8x plus 5 and x plus 8. And then we can multiply all that out to check our answer if we need to. Look at my lovely class coming in.